Right. So in today's session, I'm trying to explain few questions. Actually, I'm going to solve few questions. So this session's entirely, I'm focusing on graphs, right? So here we have a function f of x equals 2x squared minus 4q. For this problem, don't even need to draw the exact graph, right? So this function intersects y-axis at 0, minus 2. So minus 2, so which means that point, if you observe that point, x equals to 0 and y equals to minus 2. That point, very important. I can mark that somewhere here on the y-axis because the x value equals to 0. Let's say point q. Now this function intersects y-axis at that point. So just a random curve like this. This is f of x. But actually the actual shape should be a parabola like this. But don't need that information here to solve this problem. So this point, that is q, 0, minus 2. Right? So we want to compute q. So what's the meaning of this point? Right? That's very important. When x equals to 0, y equals to minus 2. So y, okay, if you want to, you can write this f of x equals x squared minus 4q as y equals x squared minus 4q. We can do that. Yeah. So because, so y and f of x, same thing. Right. So I would like to use this. So according to this point, when x equals to 0, y equals to minus 2. And more importantly, this point is on the curve, on this function. Right? Therefore, this part, this point should satisfy by the function, by this equation, in other words. So, therefore, I'm going to replace y and x by these values. Y equals to minus 2. And here x equals to 0. So 0 squared minus 4 times q. Then we can compute that. Minus 2 equals to minus 4q. Then solve this one for q. Divide both sides by minus 4. Because right now we have multiplication between minus 4 and q. The opposite operation is division. So q equals to half. Therefore, basically that function, now I can write the exact function by replacing q by half. So basically they asked about q, so we found that this is more than enough. But now we can write the exact function. X squared minus 4 times half. 4 and 2 can simplify. X squared minus 2. That's the function. F of x equals to x squared minus 2. Yeah, f of x and y you can use. You can use y or f of x. That's not a problem. Right. So that's the idea. I think you can use a very similar idea to compute the value of a. Right? So different function, g of x equals to ax squared. Right? Once again, I'm not going to draw the exact curve because it might look like this or like this, but that's not important for this problem. Okay, so like this or like this, but not important for this problem. The most important information for this question is this part actually. Passes through point, that one. Let's say point M. 2, 16. Let me mark that somewhere here. So this curve, this graph passes to this point. So like this. Whenever x equals to 2, y equals to 16. And the function is point 2, 16. Then the function g of x equals to ax squared. I think worth putting y instead of gx because we can do that. Right? Someone can write y equals g of x. And also y equals to ax squared. Y equals to gx equals to ax squared. Like that. Don't worry about those ideas. You can use that. Because the same thing. Right? Just different notations. Then the key here is when x equals to 2, y equals to 16. X equals to 2, y equals to 16. So let's use that for this problem. Y equals to ax squared. We allow to use that. Why? Because that point is on the curve. Otherwise, we can't use that. For example, you can't use 2, 18 because that's not on the curve. That point is not on the curve, clearly above the curve. Right? So that's the idea. So let me replace y by 16 and x by 2. Then solve for a. A times 4, because that's the operation between a and 2 square multiplication. Now we try to solve this one for a. So let's divide sides by 4 to eliminate that 4. So 4 equals to a. 4 and 4 can cancel. A equals to 4. Now that's the function. Y equals to ax squared. But we found the value of a, that is 4. Therefore, y equals 4x squared. That's the exact function. Maybe now we can compute, actually we can compute the y value when x equals to 4. Just need to substitute x equals 4 here. 4 times 4 whole thing square. 4 times 16, that's 64. Actually, the actual shape of this curve looks like this. Parabola open upward. Right. But this idea is quite important. Using points to compute constants like that. Similarly, I believe you can try this question. I'm going to explain this problem in the next session. Thank you very much.